In this section, we're going to look at the built-in data structures in Python, which are extremely important when building real applications. First, we're going to look at lists, and then we'll look at tuples, sets, and dictionaries. So earlier you have seen that we can use square brackets to define a list or a sequence of objects. In between these brackets, we can have objects of any type. So we can have a list of strings like this, and then assign it to a variable like letters. We can also have a list of numbers, booleans, or even a list of lists. Let me show you. So here we have a list. Each item in this list will be a list itself. So here's the first item, which is a list of 2 items. Now let's add another item to our main or parent list. This item is also a list with 2 items. So now we have a matrix, which is a 2-dimensional list. Now let me show you some cool tricks. Let's say you want to have a list of 100 zeros. You don't want to manually create that like this. That's very ugly. Let me show you a better way. So we define a list of 1 item, 1 zero, and then we can multiply it by 100. And the result will be this. Let me show you. Print zeros. Here it is. There you go. So using a star or an asterisk, we can repeat the items in a list. Now, similarly, we can use a plus to concatenate multiple lists. Let me show you. So first, I'm going to change this to 5. Now, let's define a variable combined, which is our zeros list plus letters. Let's see what happens. Print combined. You know it. So we have 5 zeros followed by A, B, C. As you can see in Python, every object in a list can be of a different type. So they don't have to be exactly the same type. We can combine a list of numbers with strings and booleans or even lists. Now, let's say you want to have a list of numbers like 0, 1, 2, 3, all the way up to 20. You don't want to type all of these by hand. There is a better way. So we have this list function. As you can see, this function takes an iterable. So we can pass any iterable here and convert it to a list. Earlier, you learned about the range function. This function returns a range object which is iterable, which means we can iterate or loop over it. So here we can call this function and pass 20. And with this, we can create a list of numbers from 0 to 20. Let me show you. So let's store it in numbers and then print it on the terminal. There you go. So 0 up to 20. But note that 20 itself is not included. As another example, let's call the list function and pass a string. Earlier, I told you that strings are also iterable. We can loop over them. So we can pass them to the list function and see what we get. Let's print chars on the terminal. So you can see each character in our original string is an item in this list. So these are a few different ways to create a list in Python. Now that we have a list, we can get the number of items in that list using the len function. So here we can print the len or length of chars. Let's take a look. So we have 11 items in this list. Over the next few lectures, we'll look at various operations around lists. So you have learned a lot about lists in Python. These lists are very useful, but if you're dealing with a large sequence of numbers, we have a more efficient data type in Python called array. These arrays take less memory and perform a little bit faster. But note that you will see the difference only if you're dealing with a large list of numbers, let's say 10,000 or more. So for 90% of the cases, you will use lists. But if you run your program and you see some performance problems, then you can see if you can solve the problem by replacing a list with an array. If you don't have any performance problems, don't try to optimize. In other words, don't solve a problem that doesn't exist. So let me show you how to use arrays in Python. To use an array, we need to import it from the array module. So on the top, from array, import array. So we have a module called array, and in this module, we have a class called array. It has the same name as the module itself. Now, we call array, look at the first parameter. This is called a type code, which is a string that determines the type of objects in your array. So here in Google, search for Python 3 type code. Then click the first link. In this table, you can see all the type codes in Python. So it's a string of one character that determines the type of objects in your lists. So if you're dealing with signed integers, you should use a lowercase I. So here, let's add I, and then as a second argument, we pass a list of integers. So we move this list here. Now we get an array. We can call it numbers. In this object, similar to lists, we have methods for adding new objects or removing existing ones. So we can call numbers.append to append a number to the end of the list, or we can use insert to add a number at a specific index. We also have pop and remove exactly like lists. And we can also access items by their index. So we can get the first item in this array. However, unlike lists, the objects in this array are typed. So here, every object should be an integer. If we try to put a floating point number here or any other kind of objects, we'll get an error. Let me show you. So I'm going to change the first item to 1.0. Now let's run the program. We get this type error, integer argument expected, got float. So every object in this array should be of the same type, which is determined at the time of creating the array using the type code. So to recap, use arrays only if you're dealing with a large sequence of numbers and you encounter performance problems. For other cases, use lists and tuples by default. In Python, we have another very useful data structure called a set, which is basically a collection with no duplicates. So let's say we have a list of numbers with a bunch of duplicate items like this. If you want to remove the duplicates, you can convert this list to a set. So I'm going to define a variable Unix. We call the set function and pass the numbers list. Now, when we print this, take a look. We only have unique items, so one is not repeated. Also note that we use curly braces to define sets. So here we can define a second set using curly braces with two items, 1 and 4. Now, similar to lists, we can add new items to a set or remove an existing one. So here we can call second.add. We can append a new number here. We can also call remove. And we can use the len function to get the number of items in a set. So these are the basics. But where sets shine are in the powerful mathematical operations that are supported by them. Let me show you. So I'm going to delete these 3 lines. These are pretty basic. And rename Unix to first. So we have 2 sets, first and second. Now, we can get a union of 2 sets using the vertical bar. So this expression will return a new set that includes all the items that are either in the first or in the second set. Let me show you. So print. Actually, I'm going to change this 4 to 5. So now when we run this code, you can see the union of these 2 sets is another set that includes all the items that are either in the first set or the second set. We can also get the intersection of 2 sets. So print first and second. This will return a new set that includes all the items that are in both first and second sets. Take a look. So the only number that exists in both these sets is 1. We can also get the difference between 2 sets. So print first minus second. When we run this code, we get 2, 3, 4. So the first set has these additional numbers that we don't have in the second set. And finally, we have symmetric difference. So print first caret second. This will return the items that are either in the first or second sets, but not both. So let's run this. We get 2, 3, 4, 5. Now, one thing you need to know about sets is that unlike lists, they're unordered collection, which means the items that we have in a set are not in sequence, so we cannot access them using an index. In other words, if we try to print first of 0, we will get a runtime error. Set object does not support indexing. So if you need to access items by an index, you need to use a list. With sets, quite often we use one of these operations here, or we can check for the existence of an item in a set. So we can check to see if 1 is in the first set, then we can print yes. There you go. So to recap, set is an unordered collection of unique items. We cannot have duplicates, and these objects are unordered. They're not in sequence. So we cannot access them using an index. In Python, we have a very powerful data structure called dictionary that is basically a collection of key value pairs. We use it to map a key to a value. A real-world example of this is a phone book. In a phone book, we map a person's name to their contact details. So we use a person's name as the key and their contact information as the value. So a phone book is a dictionary. It's a collection of key value pairs. Now let me show you how to work with dictionaries in Python. So I'm going to define a variable, point. We can set it to an empty dictionary, or we can add one or more key value pairs here. Here's an example. We set x to 1 and y to 2. So in this example, I'm using a string for the key and an integer for the value. In Python, we can only use immutable types for the keys, so quite often we use strings and numbers. But the value can be of any type. There are no limitations. So here's one way to define a dictionary. We can also use the dict function. Just like we have the list, tuple, and set functions, we also have the dict functions that we can use to create a dictionary. So let me redefine point by calling the dict function. So when we call this function, we pass one or more keyword arguments. Remember keyword arguments? So x equals 1. This is a keyword argument. We can also set y to 2. Now, I personally prefer the second approach because we don't have to deal with these quotes. I find this syntax a little bit cleaner and shorter. So now we have a dictionary. We can get the value associated with a key using an index. So point of x. Note that our index is the name of a key. So because dictionaries are collections of key value pairs, we cannot access an item using a numeric index as we do with lists. So here we're getting the value associated with the key x. Let's print it on the terminal. So we get 1. Similarly, we can change the value of x to a new value. Now let's print our dictionary. So x is 10, y is 2, beautiful. We can add a new key. So let's set z to 20 and then print the point. So now we have 3 key value pairs. Now, when reading a value, if we use an invalid key, we'll get an error. So let's look up the value of the item with the key A and then print this, run the program. We get this error, key error. There are 2 workarounds here. One solution is to check for the existence of a key. So if A in point, then we'll get the value of the item with key A and print it. Now, we don't get the error anymore. The other solution is to use the get method. So instead of using brackets and the name of the key, we call the get method. Here we pass the name of the key. Let's print it. So if the key doesn't exist, by default, it returns none. Or we can pass a default value as a second argument. So we say, hey, if you don't have an item with the key A, return 0 by default. Let's take a look. Now we get 0. Beautiful. To delete an item, we use the del or delete statement. So delete point of x. Now let's print point. and look at the results. So X is gone. We only have Y and Z. So these are the basic operations around dictionaries. We can easily add new items, remove existing ones, and look up items by their key. Finally, let me show you how to loop over dictionaries. So if we write a simple for statement for X in point, let's see what we get. We get Y and Z. So in each iteration, our loop variable will hold the key of an item. So it's better to rename this to key. Now we can print the key as well as the value associated with the key. So we write point of key. As you can see, Y is 2 and Z is 20. There is another way to iterate over a dictionary. So here we can call point.items. Now let me rename key to X and just print X. Let's see what we get. So in each iteration, we get a tuple. In this tuple, we have the key and the value. So we can unpack it right here. We can extract key and value and simply print them here, like this. When we run the program, we get the same result. Throughout the course, I've mentioned tuples a few times. In this lecture, we're going to take a closer look at them. A tuple is basically a read-only list. We can use it to contain a sequence of objects, but we cannot modify this sequence. We cannot add a new object to it, we cannot remove an existing object, and we cannot modify an existing object. So let's start by defining a tuple called point. Instead of square brackets, we use parentheses to define a tuple. So here we add a couple of numbers here, a point with X and Y values. We can also exclude parentheses, and Python will see this as a tuple. Let me show you. So let's print type of point and run this program so you can see it's a class of tuple. Now, if you have one item, you should add a trailing comma. Otherwise, Python thinks you're defining an integer. So if we run this code, you can see point is an integer, but if we add a trailing comma here, Python treats this as a tuple. Also, if you want to define an empty tuple, you should use empty parentheses. So let's run this one more time. You can see point is still a tuple. Now, similar to lists, we can concatenate two tuples. So here we have one tuple, we can concatenate it with another tuple. Let's print the result. So now we have this tuple with numbers 1 to 4. We can also use the multiplication operator to repeat a tuple. So now when we run this code, we have a tuple with 1, 2, 1, 2, and 1, 2. These are different ways to create a tuple. You can also convert a list to a tuple. So let's say we have a list of two numbers. To convert this list to a tuple, we call the tuple function. As you can see, this function takes an iterable, so we can pass any iterables here, and this function will return a tuple. So here's one example. Let's print point. Now we have a tuple of two numbers, or we can pass a string like hello world, and because strings are iterable, now we get a tuple of 11 strings. Now let me revert this back to a simple tuple. Similar to lists, we can access individual items using an index. So we can get the first item, which is 1, or we can get a range of items like items from index 0 to index 2. This returns another tuple with only those objects. We can also unpack these tuples. So we can define 3 variables like X, Y, and Z and set it to point. Similar to lists, we can use the in operator to check for the existence of an item. So if 10 is in point, then we print exists. But as I told you, these tuples are immutable. We cannot mutate them. We cannot change them. So if I try to modify point of 0 and set it to a new number, look, we immediately get this red underline. And if we run the code, we get this type error. Tuple object does not support item assignment. For this very reason, unlike lists, we don't have methods to add a new object or remove an existing object. So you might ask, where in the real world we use tuples? Here's a basic rule of thumb. Let's say you're dealing with a sequence of objects, and you want to make sure that you don't accidentally modify this sequence, you don't accidentally add a new object to it or remove an existing object. So instead of a list, you can use a tuple to prevent these accidental errors.